in computers and architecture. So I'm a digital director, which is a pretty wide-ranging term, but what it basically means is I look after everything that has ones and zeros flowing through it at the firm of architects that I work for called ADP. We have 7 offices across the world, and we do lots of big buildings. In fact, the building that you're sitting in right now was designed by us. So this is... Hopefully you like it. Don't tell me that you don't like it, because I have to go and like have a meeting with the architect who designed it later, and I need to say to him, all the students love it. Yeah. So I lecture in these kinds of things like computers and architecture, digital architecture. And then I also am on an expert advisory group for the RIBA, which is looking at, they call it data, computation, and AI. So really it's kind of thinking about how do architects grapple with AI. And I run the ethics and practice workstream for that. So if you want to talk about anything to do with that, then you're very welcome to ask questions. We probably may or may not get onto any of those kinds of things today, but if you want to ask away. And so before I was an architect, I was a software engineer. So that's kind of where I'm coming from. So the way I think about solving problems is how a software engineer would tackle those things. But before that, I was a physicist. So back many years ago, I look very young, but actually there are some gray hairs coming through. But back in the day, the first kind of way that I would think to solve a problem is to do a mathematical model of it, because that's how physicists work. And then mathematical models are great, but they don't really kind of give you the real world. And then computer scientists kind of then have a different approach to how to solve problems, which is mostly to just brute force the ones and zeros that are going through your computer and try and make them work for you. And so, yeah, I had a brief stint as a maths and physics nerd, and then I went into computing, and then I've retrained as an architect, and in between did some work with big data and machine learning and those kinds of things. So, yeah, ask away anything that you're interested in. What's interesting is that lots of architects go the other way. So you may find lots of architects who train in architecture and then go into software development because the money's better. So if you find anyone else who's ever like gone where the money's worse, let me know, because I'm like very lonely here. Right. So we are planning as much as possible to meet some learning objectives. The first one is just to understand that Grasshopper can loop, which is not something that probably any of you have ever done. Oh, if you've made Grasshopper loop before, just give me one or two. Okay, cool. But most of us are used to this kind of linear thing. And what we need to do is we need to do this kind of little bit of work to make our brains able to understand what a loop looks like and how that's going to function and how we can make it work for us. We're going to make some output using some simple algorithms within a loop. And we're going to create rules that a computer can follow to solve a more complex problem or more complex problems. And what I really want us to be able to do in this elective is to be able to say, right, I've got this problem. I don't know how to solve it. I'm going to translate it into something that a computer can solve. And then I'm going to write some kind of script or code or approach, algorithm, that the computer can churn through to give me a solution to that problem. So that's kind of where we're going. Awareness of computational limitations. You will learn this. Whether you like it or not, you will learn that computers have limits, which is if you tell it to do something 50 billion times and that thing takes it half an hour to do, the computer will say, oh, great, okay, I'll see you in after the heat death of the universe. It won't say, that sounds like a really silly thing, I won't do that. It will just say, yeah, okay, fine, I'll start doing that, and I'll see you in 15 billion years. And then everything goes grey, and you get the spinning wheel of death, and the whole thing falls apart. This is kind of one of the reasons why Grasshopper out of the box doesn't come with a looping function. because it's really, really easy to ask your computer to do something that's really stupid. And the computer is really dumb, and it will just do it. So we'll think about how do we optimize. So if we end up trying to solve a problem that involves a 50 billion year cycle, it's not going to be very helpful to us. So we need to optimize that, and we need to make sure that we can run it a little bit quicker. We're going to look at algorithmic approaches to control our outputs, and we'll think about optimization and fitness criteria, and that will make a bit more sense this afternoon. And what I'd really love is, even if you're not going to choose this elective, by the end of today, to be able to say, I've got a personal design brief, I want to do this thing, and here are some ideas for how I could approach that using a numerical way, that computer language, rather than thinking of it entirely as something that you just don't have any idea how to get a computer to start helping you. Any questions on those, by the way? That's a lot to do today, but I'll keep my fingers crossed that we'll get there. Okay. So this is how this fits in with the rest of the course. I hope you've seen this image in the module handbook. So we're talking about generative modeling skills, because these are very technical skills, and I will show you very, very technical things. But digital speculation is this word that I think is quite helpful here, because it's not just about, I've got a problem, computer solve it. It's, my problem might be, I need to be able to expand the possibilities of the things that I'm looking at. I need to be able potentially to investigate options that I didn't know existed, expand my horizons of the solution space. And this will give us the ability to do that as well. And then, not just speculation, anyone can speculate, you can chuck out tons and tons of stuff into the world, but rationalization. So how are we actually going to make this thing so it actually works, or that could be built, or can be manufactured in some way? So that's kind of where we are, those two central blue bits. And hopefully that informs things like your experimentation, your research proposal, your model making, and your proof of concepts. So it's supposed to all join together. If you've read the module handbook, this is the aim and the brief of this elective. So we're going to try and use the anemone plugin in Grasshopper. And I'll just jump straight down to the brief. The elective will introduce students to the principles and techniques of iterative design. Iterative just means again and again and again. Focusing on anemone within Grasshopper, students will learn to construct iterative algorithms where the output of one iteration becomes the input for the next. And we'll look at some of that today. When you start looping loops together, and then we can have fun. Complex and dynamic design solutions, crucially, you'll then document these processes through clear visuals and animations. That crucial means we're not just taking screenshots of Grasshopper nodes. We're actually making I'll show you some example diagrams that I think are like really nice, very clear. And when you see them, you'll be like, oh, I get it. And that's kind of what you're then going to be producing for your own personal design brief. Okay. So this morning, we're going to install an anemone together. We'll hold each other's hand, and we'll go through the process of installing a plugin. We'll have a look at some simple input rules and sequences, and we'll have a look at a couple of different ways in which they are used as a kind of map for nature. And then we're going to model, hopefully, if we get it done this morning, we'll be doing really well. But we may or may not need to push that to the afternoon, but we'll look at modeling a physical process that you will be familiar with, that you can visualize in your head, and we'll try and work out how do we translate that to something a computer can understand. And you'll be amazed at how different those two things are. And then this afternoon, we're going to look a bit more detail at how do we translate that from one thing to the other. We'll work through an example, and then we'll look at optimization and fitness, which is going to get very cool, I hope. And we'll make sure there's some time for Q&A, probably in both sessions as well. Any questions on those, or should we just kick off? Great. Quick outline of the rest of this elective. This Wednesday, Adam's asked me to give a lecture on basically the theory of computational design. So rather than just how to do it, actually, what's our architectural theory behind these questions? There's some big questions there that I think probably do everyone good to think about. And then in 2 weeks' time, we're going to explore solution spaces. We'll look at that in a little bit more detail. We'll probably look at some stochastic approaches. Stochastic just means randomness. So we're adding randomness into something in order to give us more options. And then gaining back control. Because if you add in randomness, you lose control. And then you need to kind of gain that control back. We'll do another theory lecture on Wednesday of week 4. And then we'll think about, in week 6, structure, physics, performance, and optimization. So we're going to put together Kangaroo and Galapagos and Anemone. So 3 really, really powerful plugins. Kangaroo is all about physics and structures. Galapagos is about evolutionary algorithms and fitness, and Anemone is about looping. And then in week 8, we'll look on into a little bit like the next level of where you might want to take this, which is rather than just adding blocks together, which is kind of like Duplo, we'll move on to Lego, which is a little bit more fiddly, a little bit more fun to play with, but has the ability to run faster. You can do more computations. It's much more efficient. And I personally think if you're interested in this kind of stuff, it's potentially going to be something that is going to really help you in the long run. But the main thing is we're going to be applying this to whatever personal design brief you bring. Right, so if you have the PDF open of these lecture notes, you can follow this link just by clicking on it, or you can just Google search Anemone grasshopper. And you also have to have the fun of spelling anemone, Anemone, anemone. No, anemone. So if we follow this link, you should get to this page. Anemone by Matthias Zwirecki, _1. Obviously, _0 was taken. We're still recording. Good. And then the version of Anemone that you're going to look for is just the one with the biggest number. There's 0.1, 0.26, 0.2, 0.26, and 0.4. Well, this one says major rework. 0.4. Oh, wow. It was last worked on in 2015. This is super up to date. But what's amazing is it's a very, very simple plugin. It's only really doing a couple of things. So we're not adding huge complexity to our Grasshopper environment. We have to log in. If you haven't logged in before, you need to sign up. Have you used Food for Rhino before? Great. This is really good. We're going to log in. We're going to download it. And in fact, I might just do that now. Follow this through so that the recording for anyone who... there we go. I'm going to download that. Now, if I open this up in my downloads folder, there's a really important step that if you've already just jumped ahead to like dragging this in, you need to take a breath. And does anyone actually know what the step I'm going to show you is? Say again? Unblock it. Fantastic. You're on it. You're like 3 steps ahead. So when you download a file from the internet, Windows thinks, danger, Will Robinson, danger. And so one of the things that you need to do is you right-click, choose Properties, and this little thing says, this file came from another computer and might be blocked to help protect this computer. So if you don't unblock it and you just put this in your Grasshopper, it'll look like it works and then nothing will work, which is really frustrating. But you're just basically telling Windows, hey, calm down. It's okay. I trust where this file has come from. You can run whatever code is inside it. So we're going to click the unblock button and we'll click apply. And then I've already downloaded it, so there's a little brackets 1 afterwards. Then there's a couple of different things you can do. So if you're running Rhino, we'll fire up Grasshopper. This is the slow way. Then I'll show you the fast way. The slow way is we'll fire up Grasshopper. And I think what I managed to do, apart from a few different plugins, I've managed to clear out all the other plugins that I would otherwise have. So I've got a Grasshopper environment that's kind of similar to yours, hopefully. Although Ladybug is still clinging on. Oh, as is V-Ray. Here we go. So we go to File, Special Folders, and then we look for our Components folder. What that will do is open up the folder into which we want to put that GHA, that Grasshopper assembly file. You'll see I already have that in there. The fast way is, the reason this is slow is because I'm going to drag this guy in, and then most of the time, you'll then have to restart Rhino and Grasshopper in order for it to pick that up. Whereas really all we needed to do was just find the file location, the folder location, and then we can drag it in before we even start Rhino up, and then we only start Rhino once. So a useful thing to do is type app data %. So %app data %, and then we press enter. And this will take you to our app data roaming folder. And one of the folders that you'll see there is called Grasshopper. So we'll click on that. Then we'll go to Libraries. And lo and behold, here you are. So %app data %. This is useful for other programs as well if you need to get to your app data folder. Then Grasshopper, then Libraries. Drag and drop it in once you've unblocked it. And then when you start up Rhino for the first time, it'll pick up that file. So I've hopefully just saved you all about 10 minutes every day when you added a new thing. Okay. I will give you just a couple of minutes to get that installed and give me a wave and a shout if you're having any trouble at all with that one. Yeah.
If I already have it in my components folder, should I delete it and then?
You probably got the same. If you got the same version.
Yeah.
Yeah. Then just leave it. It's fine.
Even though I didn't unblock it.
I would. Yeah. Once you put it in your components folder, you can unblock it from there if you need to, but you'll need to restart Rhino. Here we are. How are you getting on? Give me a wave when you're done, or a thumbs up or something. Give me a wave if you're struggling, got any issues. Because if we can't do this, then the rest of the day is going to be pretty rubbish. As in, the only thing we're looking at is this one plugin. So if you get some issues with it, then let's sort them now if we can. This is a completely useless chair. Unless, can I sit here? This desk is very high. If I sit here, then I can't see any of you. All right, looks like I'm standing all day. Okay, fine.
Maybe you can change the height of the chair?
Yeah, I've tried, but that's as high as it goes. So I don't know why they put that chair with this desk, but hey. Oh well. Okie doke.
Maybe you should talk to the architect.
Yeah. I'll have stern words. Right. So, I'm just going to check this guy on the right-hand side. hopefully you've all downloaded the Grasshopper definition that I sent to you. What I'm actually going to do is I'm going to fire this up here. There we go. And you'll see there's a ton of stuff in this definition. But what we're going to do is basically we'll build all of it step by step. And this is a useful reference. So we're going to do a couple of things. The first reference that's very useful is, here's the slides. And we'll work through the slides. And you'll see that on the slides as well, I've got the definitions themselves. So even if you can't open the Grasshopper file that I've shared with you, I've put everything on the slides. So you can always come back and read those at your leisure. What I want to start with, before we even get into the Grasshopper thing, is just this question, which is this sequence that's on the board, on the screen. Why don't you just take 30 seconds? You shouldn't need long. Hopefully, some of you already recognize what's going on here. Answer these questions. What comes next? And you probably work with the person sitting next to you. Grab a pen and paper, see if you can work out what's going on. Work out the next few items in the sequence. And then choose the two numbers at the beginning to be different numbers and see how that changes the sequence. Happy with that? Okay? All right, off you go. Take half a minute, see if you can work it out. Right. What comes next?
34.
34. What comes after that?
55.
Yeah. Then?
89.
Then?
144.
Yeah. So what's going on? Have you all worked out the rules? Yeah? What's the rule? You add the adjacent numbers. Yeah? Be a bit more specific, because we're going to get a really dumb computer to help with this. And computers are so dumb. You have to be really specific about what you want. Otherwise, it's just going to be like, huh? So what's the rule?
The next number is the sum of the previous two numbers.
The next number is the sum of the previous two numbers. Great. That's an English sentence. And we're going to try and work out how do we computerize that. Okay, cool. If you choose two different starting numbers, and that rule, right? The next number is the sum of the previous the two numbers. What that means is that kind of tells you that the first two numbers are going to be quite important. So has anyone chosen two different numbers to start with and seen what happens to the sequence? No? 0 and 3. Yeah, great. Okay, so do 0 and 3. Then what's the next number? 0 and 3. Do I have a I'd love to have a whiteboard pen, but I clearly don't have one. I should have brought one with me. So if we start 0, 3, then the next number is going to be 0 plus 3 is 3. Then 3 plus 3 is 6. 6 plus 3 is 9. 6 plus 9 is 15. So what's interesting here is 0, 3, 3, 6, 9, 15, 24. Well, yeah, but what's happened is you've just taken this sequence and you've multiplied all the numbers by 3. So by choosing two different starting numbers, you'd have thought, oh, I'm going to get a different sequence. Well, you got the same sequence, it's just that you stretched it out. Let's choose 1 and 1 as the starting numbers. And then what do you get? It's the same sequence, it just doesn't have that 0 at the beginning. And in fact, actually, so this, what we have here is called the Fibonacci sequence. You may have come across this term, the Fibonacci sequence. And it starts 0, 1. If you start 1, 1, it's called the Lucas sequence. It's got a different name, even though it's almost identical, but it just doesn't have that extra 0 at the beginning. Who knew? So what's going on here is when you start interrogating these things and doing the work on a piece of paper, have you noticed how it changes the way that you're seeing that thing on the screen? Yeah, your brain kind of goes, oh, I know what I'm looking for. I know the patterns I'm trying to get to. And then when you start playing with it, you can kind of run through this process where you understand something that you didn't understand before. And all we're doing is playing with numbers. We haven't even touched a computer. We haven't touched Grasshopper. We haven't touched anything. This is the first thing to learn about this process of trying to get a computer to solve something algorithmically. Is the first thing you do is do not go into Grasshopper. The first thing you do is you get a piece of paper and a pen, and you work it out. And you try and see if you can do it. I mean, do it manually, do it with a sketchbook, because you're free and then your brain is engaged. Because now we've got the rule. Great, okay, we're all happy with that. Now what we're going to do is we're going to try and get Grasshopper to do it. And we're not going to use any loops. We're just going to try and get Grasshopper to do what we've just tried to do. So here we go. We come up here. And actually what I'm going to do is I'm going to maximize this because we're not doing anything in the Rhino viewport. We're just going to do stuff in Grasshopper. So the first thing, if I come up here and we'll have a look at this sequence here. The starting numbers are 0 and 1. And then what was the rule? You take the last two numbers and you add them together, and that gives you the next number in the sequence. So I've got this thing here. I can just type in a plus, and it gives me an addition node. And I can take my 0 and my 1, and I can wire them in, and that adds them up, and it gives me the next number. You with me so far? And then what I'm going to do is I'm going to take this number and add them together, and it gives me the next number. And then I take this number, and I add them together, and it gives me the next number. Let's just try and build this because I really, we've got the example right here in front of you, but we're going to go slow. We're going to take the time. We're going to build this thing just like we're doing on a piece of paper. Little trick that I use all the time is rather than a number slider, you're used to this thing where you just type like 5 and you get a slider and you can like change the number, right? Well, most of the time I know the number I want and I'm not going to change my mind. So what you can do is you can use // and you create a panel. Well, a panel is cool and all because it's like you just type a thing in that you want. But what you can do is you can type // 0 and it will give you a panel with a 0 inside it. Have you used this shortcut before? Yeah? Cool, good. All right. So I'm going to add 0 to 1 And the results, I'm going to put it into a panel. I'll make my panel a bit smaller. Bloop. And you can right click on that and we're going to say don't draw the indices and don't draw the paths. So it's just a super simple just display of the number. And then I'm going to copy this. I'm going to take the last number and the number just before it. Now, are you getting bored yet? Yeah? No? You just keep going. Oh, okay. How far have we got?
Not too far.
Not too far. Yeah. Okay. You're getting there. But if I asked you, can you give me the first 100 Fibonacci numbers?
Maybe not.
Yeah. I mean, you could do it, but you'd have to basically copy and paste this 100 times. All the way along. And, you know, we've got better things to do with our time. So wouldn't it be great if, instead of this input-output linear approach from left to right, we could somehow basically have this rule where we just say we take the last number and the number before that, we add it, and then we put that result into the list, and then we loop around that process again and again and again and again and again. That would be cool, wouldn't it? Okay, so if you scroll down, that's exactly what's going on here. We're going to build this from scratch because I've got it here just as a reference. You've got it here as a reference. So if you get something wrong, you can come back and say, oh, what's going wrong here? But let's build it. In fact, we're going to leave this on the screen on the presentation so we can come back to it and we can use it as a reference. So here we go. The first thing we're going to do is we're going to need to use the loop start component. And you'll find it under anemone. And there's a really cool little shortcut that I only found out about like 2 months ago. If you hold Control and Alt on your keyboard, do you see your mouse has a little blue eye next to it? Control Alt, and then you click on an item and hold down the mouse key, and it shows you where to find it in the menu. It's cool, right? And what's cool about that is, look, I've done all of this and you've got access to it. And you're like, okay, I want to put this, I want to find the vector cross product node. But where is it? I don't know where it is. Well, Control Alt, hold down your mouse key. There you go. That's where you find it. Okay. So we've got a loop start. And we've also got a loop end. And coming back to this little diagram here, this arrow, this is kind of what I said, like, wouldn't it be great if we could just go round and round and round on the same rules again and again? Anything that we put in between this loop start and this loop end is kind of like is going to basically feed the information into the loop. We can do something with it, and then it will feed it back into the start again. And then it'll go round that loop as many times as we tell it to. So the thing that you'll notice is there's this green bit here which says control. So now I'm controlling the loop. I'm controlling how many times round I'm letting it go. How many goes round the roundabout am I allowing this thing to happen? Save, by the way. How many times are we going to go around this loop, looking at that definition on the screen? 10 times. Amazing. Then there's this also little button called reset. Because what often happens with loops is that you do stuff with your data and it's not quite what you wanted. And what reset does is it just clears out everything and sets it back to 0 again, and then it will start the loop afresh. So if you change something inside the loop, then refresh or reset is what we're always going to come back to doing. And that is a button. So if you just type button or button, as I have written here, button. Have you used the button node before?
I've used the Boolean toggle.
Oh yeah, you can use the Boolean toggle as well. So you can use the Boolean toggle. What the Boolean toggle will do is you double click it to turn it true, and that resets the loop. And then you double click it to turn it off again. And then that just lets the loop go. But with a button, what it does is you click it and it sets it to true as long as your mouse is held down. And then when you let go, it goes off again. So rather than clicking 4 times, I only have to click once. So it does the same thing, it's a bit quicker. So I'm gonna wire in this button to the trigger. Fire like a gun. We're gonna say I'm actually gonna do 15 and then just drag this down to 10. And repeat this loop 10 times. And then I need to feed in some data. So going back to here, you've got input, you've got rules, and then the result is a sequence. Everything we look at today has exactly the same pattern. An input, some rules, and then the output is a sequence. Here we go. Well, what are we going to put in? Well, we're going to put in 2 starting numbers. You need to provide 2 for a Fibonacci sequence. If you just provide 1, then, well, the rule is the one that came before and the one before that. Add them together. But what came before the one number? Well, there's nothing there. So you can't start unless you have those 2 numbers given to you. So here we go. I'm going to take my panel. I'm going to right click and click multi-line data. The first line is going to be 0 and the second line is going to be 1. So now I've got 2 bits of data, 0 and 1. I'm going to feed that into my data. Now this is giving me an error. And it says, it's orange, please connect loop end with loop start. Well, if they're not connected, Grasshopper has no idea whether this thing and this thing are part of the same loop. It's not just going to float in the middle of nowhere. So what you have to do is this thing that looks like a little chevron comes out, and this thing has a little chevron on the other side, and we let go, and it links them with a dashed line. And you're great, but it's still orange. And it says, please connect loop end with loop start. Well, I just did. What's going on? Well, we're feeding in data. We're going to do something to that data, but then we need to send the data back to the beginning. Because if you just do something with the data and then send nothing back to the beginning, the next time the loop goes round, it doesn't have any data to do anything with. So what we need to do is we need to make sure that the data has a connection between there and there. In fact, actually, yep, there we go. We just need to reset it. And so now what's going on is 10 times we loop around, sending this data back around again and again and again and again. Well, what do you think the output's going to be? Exactly the same as it was before, right? But now we can start doing stuff with that data. So what we can do is we can say, look, I'm going to look at this. It's a 0 and a 1. And what's the rule? Let's say the rule again. You came up with a really good way of putting it. Is it Ahmed? You said the rule for the Fibonacci sequence. What was the rule?
The sum of the previous numbers. So n minus 1 plus n minus 2. N being the current digit. Excellent.
Right. So how in Grasshopper are we going to tell it to do that?
We take a list item and take the previous.
Boom. List item, because we're sending in a list of numbers. Well, list item has a really cool thing, which is that the index doesn't have to be 0 or 1. The index can be negative. And if you feed a negative item, a negative index into a list item, it goes backwards through the list from the end, not forwards from the beginning. And that's exactly what we want. What we want is an index of -1. And we need to make sure that wrap is set to true. So it'll sort of go back through the list. And let's look at this. If we hover over that, it's going to give us a 1 because that's the last item in the list. The list item node also has a really cool hidden feature. Have you noticed this? When you zoom in to a node, sometimes it gives you more buttons that you didn't see before. And if you hover over, this is n-1. This is the last item in the list. If I click a little plus up here, it will give you I and -1. And this I is the index that you typed in, which is -1, the last one in the list. This one is the one before it. Well, that's exactly what we wanted, right? We want the one at the end of the list and the one before it, and we need to add them together. So here we go. I'm going to add these results together. Boom. And then what's my result? Oh, my result is 1. Well, that's the third number in the list, right? 0, 1, 1 is the next thing in the list. Now, if I put this result, yeah?
Before you continue,
Yeah.
I don't know why, but my list item is still orange.
Have you reset the loop?
Well, yeah.
Because it's not sending any data, and then the list item's like, I'll get you the last item in the list, but the list is empty. So I don't know what you want me to do. Cool.
I don't understand why we put -1.
Right. I really wish I had a board pen, because I'll do what I can on the screen. Right.
Isn't there a word there next to Mike? Right there? In this box, yeah.
In the box? No, can't see one. Can you see something I can't?
Oh, no, it's not one.
You can try this, but I'm not sure if it's permanent or not.
Ah.
A little dirty.
Oh yeah. The one difficulty is I don't know whether we'll be able to rub it out. It's okay.
But
We
they
can.
clean.
Who's they? Who's they? The elves.
Yes.
Right. I've got a list here. The index is like this, right? And then you can put whatever data you want into the list. So let's say this is the number, this is the string hello. This is the number 324. This is a line. This is a curve. I mean, you can put any data into the list. And then this thing here is an index, and it allows you to find that item again later. So what you say is, I want item 3 in the list, and then it'll give you the curve. And you're like, oh, great, okay, thanks. That's exactly what I wanted. The thing about lists is the list knows how long it is. So this list knows that it's got 5 items, 0, 1, 2, 3, and 4. That's 5 items. So you always have to add 1 to here, right? If I told it I want the 0th item, then that's very easy to do. But that thing that we had before where it said wrap list, imagine now that the list carries on forever and ever in 2 directions. So the first direction it carries on in is back here, and that's 4, 3, 2, 1, 0. 4, 3, 2, 1. Yeah? You get that? And then this is 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. If you wrap a list, it means you could feed it a number like 52, and it will just find the 52nd item in the list, and if it happened to be a 3, then yeah, it would work. Now, so follow me so far? Well, if it works to say 0, 1, 2, 3, and 4th item, well, it also works to say the -1th item, the -2th item, the -3th item. So this is -1, this is -2, this is -3. And by definition, that's the last item in the list, just repeated back. So -1 gives you the last item in the list. -2 gives you the second last item in the list. Happy with that?
Yeah.
Cool. So that's why we type in -1, and then we add another one on the beginning of that, which is -2. Now, what I'm going to do is I'm going to feed that result into here and watch what happens. Where's my output gone? What's happened to my output from the loop? It's just the same. I've run this loop 10 times. So what's going on is I feed it 0 and 1. I add 0 and 1 together. And then I put that result into the data. The data gets sent back to here and pops out down this wire. Well, what does the data say? Well, the data just says 1. And then that data that gets sent to my list. The list, in this case, has... Oh, there we go. Oh, I needed to reset it. There we go. 1024. The list, in this case, now has one number in it. And it's only got one number. But go back to this guy. If my list only had one number in it, and that was 0, and that was the number, I don't know, 329, minus 1 minus 2 is still going to be that same number, right? So it's just reading that number as many times as you like. And then it adds it to itself, which effectively doubles it, and then gets sent back again. So what we've made, and you might recognize 1024 is a square, right? You just added a number to itself over and over and over again, and we ended up with 1024. If we run it, it's a power of 2 actually, no, sorry, there we go. Run it 8 times, we're going to get 256, because that's a power of 2. This isn't quite what we wanted from Fibonacci. What we need to do is, instead of just sending that result back and then ignoring all the rest, we need to keep hold of the data that we had before, and we need to add the new value to the end of the list. So every time we run the loop, the list is going to get larger. And then when we read the last items in the list, we're not reading 4 and 3, we're reading 5 and 4. And then we add another thing to the end of the list and we send that back, and then we add when we read 6 and 5, not 5 and 4. So what we need to do is we need to take this data that we got given here and we need to merge. Let me get rid of those layers, those arrows. I'm going to merge that merge that data with the addition that we've just done. And now let's look at what we've got here. The data we got sent in was a list of numbers. We've added the last 2 together, and we've added it to the end of the list by merging the 2 together. I'm going to send that through to the data. And now if I reset, magic happens. Do you recognize these numbers? Yeah? Cool. I think we're going to take 5 minutes. Let's do a quick question and then we'll take a few minutes. You need to make sure you reset. So let's just go through, just check it against this guy here, which is we are sending the data that you start with is a 0 and a 1. We send it in, we take it to a list item node, and we want the last 2 items in the list. We add the 2 together, and we feed that result into a merge node. What do you find there?
Maybe I did something wrong with the panel, or it's just like after the addition part, the line is orange. I don't know.
After the addition?
Yeah.
Ah, okay. Are we sure that the index is set correctly?
It's -1, right?
So, yeah, so I can just put this on a panel so we can definitely see what we're doing here. The -1 index and then the one before that. We're making sure that we're not doing the one after it, because the one after it's going to be the first in the list, not the last in the list. maybe a couple of people next to you have a bit of a play. See if you can figure it out. This is a really, really good learning case because we're not worrying about geometry. We're just worrying about adding numbers together. It's super simple, but if we can get this working, then everything else becomes much, much easier. The list item. Oh yeah, make sure wrap is turned on. Is that where it is? Set Boolean to true. It should be. Let's have a quick look. So your panel that you were sending in the data, this might be true for some other people as well. When you send in the data right at the beginning, this guy here, if you make a panel and you just go 0, enter 1, that isn't 2 bits of data. That's one string with a line break in the middle. Whereas if you right-click that panel and click multi-line data, now it'll turn into 2 items in a list. And the 2 items in a list is exactly what we need in order to... how are we all getting on? Give me like a thumbs up if you've got a Fibonacci sequence working. Great. Nearly? Okay, good. What I want to do is come back to these questions. Can you work out the next few items in the sequence? Yeah, right, you can, because all you need to do is just drag that guy up, and it'll give you the first 44 Fibonacci numbers. What's cool about the first 44 Fibonacci numbers is how absolutely ginormous they are. They get pretty big pretty quickly. Then, is that right? Yeah, that's right. Then, if you change the starting numbers, what happens? Oh, well, you can explore that to your heart's content, right? Let's try 4 and 5. There you go, completely different Fibonacci sequence, done like that. Now, it took you a lot longer to build this definition. Actually, there's a point at which, do you see my addition has gone red? Now, if you pull this guy up too far, Grasshopper just stops being able to cope with the numbers. It can't cope with an integer that's too long. So be careful. I would say probably don't go beyond like 25. But it gives you a good starting point. It takes longer to set up this loop. It took us, 40 minutes or something from start to finish, install an enemy, get everything ready, solve all of the problems. It's now 20 past 11. So yeah, half an hour, 40 minutes. But we set this loop up and now you can play. It takes you longer to start with, but saves you time in the long run. Not everything saves you time in the long run. Only things that actually really do save you time in the long run are worth doing like this. So we're going to be careful about what we decide. This is kind of human nature, right? You think, oh, I kind of like playing around with these Grasshopper nodes. Maybe I'll do that for 8 hours, but have absolutely zero output that was particularly helpful at all. Who's done that? Who spent a day just like rotating a Rhino model, but not doing any work? And it feels like you're doing something really important, but really you're not. So we always have to be a bit careful that we're not getting sidetracked into something that's actually just taking up huge amounts of time, This is useful because if someone had asked me what's the 25th Fibonacci number, it probably would have taken me roughly the same amount of time to do it by paper as it would have done with a script. But if someone asked me that what's the 50th Fibonacci number, I'll definitely win this round, you know? So you have to choose where you're going to put your effort there. Any questions on that before we carry on? We'll have a 5-minute break, get a cup of coffee, and then we'll push on with something a little bit more geometrical. Sorry, say again? Yeah. The counter is really useful. We're going to use it later. What happens is every time it goes around the loop, it increments a number. So it starts at 0. And every time you go around the loop, then the next time that number is 1. And then the next time that number is 2. And then 3. And then 4. And then 5. And so if you run the loop 24 times, this number will now say 24. Yeah? So it's basically keeping a count of how many times you've gone round. And you can use that number in clever ways. We're going to do that later. All right. I'm going to stop the recording. We'll have a cup of coffee.